Hi everyone, welcome back to Sri Sampath Vinayaka Learn Music channel. Now, in this video we will discuss about the operations on sets. In that, the first operation is union of sets. Union of sets means, let us suppose A comma B are two sets. If I will write a new set which consists of all the elements of A and B, then that new set is known as union of the sets A and B. In general, in English we know the word union. Union means the combination or togetherness of some people or some things. Okay. Here in these sets, union of sets means, let us suppose A and B are two sets. Then if I will combine all the elements of A and B into a new set, then the newly formed set is known as union of sets A and B. So, coming to the definition, the set which contains all the elements which belongs to either A or B or both is called the union of sets A and B. Or in other way, let A and B be the two sets, then the union of A and B denoted by A union B, and that is the set of all those elements which are either in A or in B or in both A and B. Simply we will write that as A union B is equals to X such that X belongs to A or X belongs to B. If an element belongs to A union B means that element may belongs to A or that element may belongs to B. Okay na? This is the set builder form of A union B. Now see one example we will discuss. A is set of 1, 2, 5, 7. B is set of 2, 3, 5, 11. Then A union B means, I already told you, we have to write all the elements of A and B in a new set. This is the new set. In that new set, I will place 1, 2, 5. Okay, na? See, here we have 3. So, 1, 2, 3, 5, 7, 11. Okay, if any element repeats, we know in the properties of sets, no element is repeated in the set. So, as we are having 2 and 5 in both the sets, we have to write only once in the new set. Okay, that's why this is said to be the union of A and B. Once again I will tell you, A union B means we have to write all the elements of A and B in a new set. That newly formed set is known as A union B. Okay, here we are going to discuss the note points. See, if A is subset or equal to B, that means A is subset to B means all the elements of A are there in B. Now this B set is greater, maybe. So then A union B is always B. Why? Because if I will write the elements of A and B together in a new set, definitely I will get B. Now A union mu. Mu means we know universal set. A union mu means that mu we will obtain. Why? Because mu is the biggest set. From mu A is obtained. So for A and mu, if I will write union, then I will definitely get mu. And A union pi. Pi means nothing is there in that set. So A and pi, if I will join together means I will get A only. And A union A dash. A dash means complement of A. A dash means not A. A and not A. A union not A means A, not A we are joining. Then I will definitely get the universal set mu. I hope you understand. Now the second operation on sets, that is intersection of sets. Let us suppose A and B are the two sets. Then to find the intersection of A and B, we have to write the common elements in both A and B in a new set. That common elements set of both A and B is known as intersection of that sets A and B. That simply represented as A intersection B, like this. A intersection B we will represent. And that is pronounced as A intersection B. This symbol is intersection. Okay, I hope you understand that. A intersection B means I have to write a set which consists of all the elements which are common to both A and B. Okay, na? Only common elements here in this set we have to write. Okay, see the definition here. Let A and B are the two sets. Then the intersection of A and B is denoted by A intersection B, and that is the set of all those elements, okay, which are common to both A and B. Okay, and its set builder form is if any element of A intersection B, if I will take, that must belongs to A and that belongs to B also. That's why simply I will write the set builder form of A intersection B is X such that X belongs to A and X belongs to B. It's a very important one, ma. Now coming to an example, see, my A is set of 1, 2, 3, 5, 6, 7, 8. B is set of 1, 3, 5, 7. Then A intersection B means I have to list out the common elements of both A and B. Here see, ma, for A and B the common elements are 1, 3, 5, 7. Okay, na? So those are placed in a set. That obtained set is known as A intersection B, ma. Understand? Now example 2. P is the set of 2, 4, 6, 8 and Q is the set of 1, 3, 5, 7, 9, ma. Then P intersection Q is empty because for this P and for this Q there is no element in common. If there is no element in common means this set becomes empty. If there is any common elements, then those are placed in this set. But there is no common element, that is why that set P intersection Q is empty, ma. I hope you understand. If the intersection of any two sets is empty, then those two sets are known as disjoint sets. We already discussed it. So here this P and Q are known as disjoint sets. Disjoint, there is no common element. Okay. Now see the observation points, my here. If A and B are disjoint sets, then A intersection B is empty. As A intersection B is empty, the number of A intersection B is 0. Why? Because there is nothing in the set A intersection B. Nothing is there means its cardinality is 0, ma. So number of A intersection B is 0. Coming to the second one. If A is subset to B, that means all the elements of A are there in B. What are the elements common for both A and B, ma? The elements in A. That's why A intersection B is A. Now A intersection mu. A intersection mu means A is a part of mu. So if I will take out the common elements for A and mu, I will definitely get A. So A intersection mu is A. Next, A intersection pi, ma. A means it is having something. Pi means nothing is there. Okay. Is there any common for A and pi, ma? No common element. So A intersection pi is pi. Next, A intersection A dash. A means A. A intersection A dash, no, ma. A dash means not A. To A and to not A, if I will take the common elements, see, ma, nothing is there. Why? Because in A I have A. In not A I don't have A. So for A and not A, if I will check the common points or common elements, nothing is going to be placed in the intersection set. That's why it is going to be empty, ma. Okay. Now see the third operation, difference of sets, ma. Let A and B are the two sets. Then the difference of A minus B is the set of all those elements which are in A but not in B. That means let us suppose A comma B are two sets, ma. Then the difference of sets A and B is represented as A minus B, and that A minus B is going to consist the only elements of A. The only elements of A. That means if there is any common elements for both A and B, then firstly we have to remove those elements and then we have to write the elements which were left in A while we are writing A minus B. If I will write B minus A, then firstly we have to remove the common elements of B and A, then I will write the only elements which were left in B. Okay, that is A minus B or B minus A, ma. So simply A minus B is the set of elements of only A. Okay, na, ma? See, with an example you can understand easily. Before going to discuss an example, I will tell you the set builder form of A minus B. So let us suppose A minus B is the set. Each element of A minus B is like X, let us suppose. Then that X must be from A and that X must not be from B. That is the set builder form. So A minus B is having all the elements like X, and X belongs to A and X does not belongs to B. Okay, Nama? Very important set builder form. Now, A is 3, 6, 9, 12, 15, 18. B is 2, 6, 8, 10, 14, 18. If I want to calculate A minus B, then write A minus B is equal to set A minus set B. Here you have to remove all the common elements first. Here see 6 is common and Seema, here 18 is common. So I have to remove those common elements. Then what are the elements left in A ma? 3, 9, 12, 15. That is A minus B. If I want to write B minus A, then write B first minus A. Here also you have to remove the common elements. That is 6 and also the common element here is 18. By removing the common elements, okay, we have to write only the elements which were left in the first set. That is 2, 8, 10, 14. That is B minus A. By observing these two, A minus B and B minus A are not same. So A minus B is not equal to B minus A. Okay, now those two will become same. Okay, now when A and B are same or A and B are empty. If A, B both are same means all the elements are going to be cancelled. Then A minus B is empty. B minus A is also empty. That is why A minus B and B minus A, okay, now will become equal if A is equal to B or A is equal to B is equal to empty. Unless those are equal, A minus B must not be equal to B minus A. Now, for any set A dash or A complement is mu minus A. Okay, now remember that. B dash means mu minus B. C dash means mu minus C. Like that. Now, we will discuss the symmetric difference of sets. Symmetric difference of sets means let A comma B are two sets, then the symmetric difference of A and B is represented as A delta B. This is the set which consists of all those elements which are either in A or B but not in both A and B. That means I have to write a new set which consists of the elements of either in A or B but not in both. That means the elements which belongs to either A or B but that element will not belongs to A and B. Okay, that simply indicates we have to remove all the intersection elements from the union set. That indicates our A delta B. I hope you understand that. Now see the set builder form of A delta B is X such that X belongs to A and X does not belongs to B, or X belongs to B and X does not belongs to A. That means the X belongs to either A or B but not both A and B. See, that is symmetric difference of A and B. Okay, now simply we will write A delta B is A minus B union B minus A, or A union B minus A intersection B. These are the two formulas for the symmetric difference of A delta B. We will discuss this one with an example. Let A is the set of 1, 2, 4, 6, 8, 10, 12. B is set of 3, 6, 12. Okay, if I want to find A delta B, I need to find A minus B and B minus A. So I am going to calculate A minus B. We know A minus B means the only elements of A I have to write. That means the common elements I have to remove. So here I removed that common element 6 and 12. Then I have to write the elements which were left in A. So that is 1, 2, 4, 8, 10. Okay, if I will write the elements which were left in B, then that will become B minus A. So then B minus A is 3. Now I am going to find the A delta B. A delta B is A minus B union B minus A. As we obtained A minus B as 1, 2, 4, 8, 10 union B minus A is set of 3. So that gives us A delta B. 1, 2, 3, 4, 8, 10. I hope you understand this. Complementary set. Complementary set means first we have to take one set A. Let A be a set. Then the set of all elements which are in mu but not in A is known as complement of A. That means if I want to find the complement of B, then I have to write all the elements which does not belongs to B. Okay, we have to remove all the elements of B from the universal set then whatever I will get, that is said to be B complement. If I want to find A complement, then I have to remove all the elements of A from that universal set mu. Then whatever the elements I am going to get, that set is going to be known as A complement. Okay, now coming to the definition, let A be a set, then set of all elements which are in mu and not in A, which are in mu and not in A is called complementary set of A. Okay, and it is denoted by either A dash or A complement. A dash or A complement. See, A complement or A dash is x such that x belongs to mu. I have to write the elements which belongs to mu and that element does not belongs to A. Okay, simply I may write the same set builder form as all the elements of A dash are like x and x is not an element of A. Understand? See, A dash formula is mu minus A or B dash formula is mu minus B. If you want to write the complement of C, okay, then C dash is equal to mu minus C, like that. We will discuss the complement of a set with an example. Let us suppose the universal set mu is the set of first 9 natural numbers. And now A is taken as 1, 3, 5 and B is taken as 7, 8, 9. Firstly, we will find A dash. A dash means according to the formula mu minus A. That means we have to remove all the elements of A from the universal set. So this is the universal set, from that I am removing 1, 3, 5. Then what are the elements left with us, 2, 4, 6, 7, 8, 9. Okay, that is A dash or A complement. Coming to B complement, I have to remove all the elements of B from mu. So mu minus B. Then 1, 2, 3, 4, 5, 6 is our B complement. I hope you understand. Thank you for watching. Like the video and share the video with your friends. Thank you for watching.